Okay, hello. So you should have your free response question out in front of you, the one for sound. So I know that it's going to be a little bit difficult to see this. However, again, you having that in front of you should make it a much easier task to follow along. So with that said, let's begin. All right, so for this question here, we're told that we're going to write two unrelated methods, and that unrelated part is actually very important because the idea here is, whereas there are many free response questions where you write two methods and the second method uses the first, in this event, we're not going to have that happen. These two are unrelated. This one will be written and do its own things, and this one will do something very different. Now, what are they going to do? Well, this first one here, according to our description up here, because that's probably where I should start, is reading this description. Start when I, actually begin the problem. It says that the limit amplitude method, which has a parameter of limit, changes the values in this sound, that's the samples part up here. So it changes these, all the integers inside there, that are exceeding the limit. So if it exceeds the limit, either by being bigger than the positive or less than the negative, we need to change them. And at the end of it, it's going to return the number of them that have been changed. So let's go ahead and dive in. All right, we are shown an example here just to make it a little easier. So again, notice how from the beginning to the end, there are no samples that exceed 2,000, either positive or negative, in the second part. Any that did in the first have now been limited. All right, so let's go and write that limit amplitude function, method, sorry. Start off like that. So there are a few things we need to do. First, I'm going to need a way to keep count of how many have been added. And I might just save that for the end, and instead let's start with actually changing them. So I'm leaving myself a little bit of space up here. I'll move my hand out of the way. I'll leave myself some space up here because I want to make sure that we are still going to have that ability, that space to put it in. All right, so for int I equals 0, I is less than samples dot length, and again this is to have us go through all of the samples, plus plus I. It is an array, so again it's going to be length, and then what we're going to do is we're going to check for each samples at I. Notice it's brackets, it's an array, not an array list. Samples.I, for each of those that is bigger than limit, then I'm going to set samples at I equal to the limit. Else if samples at I is less than negative limit, then set it equal to negative limit. And that's just -1 times limit. So right here, we have these two if statements together, take care of it. Now, here's where we're going to have to handle another part. I'm going to show you something, and it's going to be because we didn't plan this out perfectly. First, we're going to close up our for loop, because we're all done with it. We go through, we've changed them all, but now we have to actually count up how many that we changed. So here's what I'm going to do. I'm going to first get an integer up here, a number for our count. Starts off at 0. And then what I have to do is I'm going to need to write in some brackets here and put count plus plus into there. So I'm going to take this variable and I'm going to increment it each time I have one that exceeds the limit in either direction. All right, and just like that, we have managed to get that. Now, of course, we are not finished yet, because remember, this is a method that returns an integer, so we need to actually return our count. Okay, and that is the end of it. Get a count variable, set it to 0, change all the samples. For each one you change, increment the count, return the count. Straightforward. All right, now, for the next one. The next one is called trim silence from beginning, and it's a little more challenging. Take a look at that and notice the changes from the first version to the second version of samples. All right, so the big difference there is these 4 zeros aren't there. Now, you might be wondering, okay, how do I remove from an array? And the answer is you can't. Arrays are not dynamic in that way. They can't be altered like that. Let's move this page up just a little bit. Okay. So they can't be altered like that, but yet that's what they're asking. So what it has to be then is this one up here is the old samples array, and then this one is like a new samples array. I'll just write S new. This is a new array. What we're going to do is we're going to get the size, get the length, get the new length. You know how big it should be after we remove these zeros, and that's just going to be counting these up, and then doing length of samples minus whatever number we have here. In this particular instance, it would be 16 minus 4 to get 12. And notice that this 15, that's 11, because again, last index is 1 less than the length. So we have to get that length, then we have to create S new as a new array, then we will copy the values, copy the values into S new, and then lastly it would be samples equals S new, and that's actually the line of code that we're going to write, samples equals S new. Because if you have two arrays and you set one equal to the other, it will take on everything that array has, which is important because S new will only exist for the duration of the method. Because we are creating it inside the method, it only exists inside the method. It doesn't have existence elsewhere. So let's go ahead and begin this. We have to first start by getting the length. So that means we have to find out where our last zero, or our last consecutive zero is. All right, so we'll make up a little count for our zeros. Int zeros equals 0, because you know we want that quantity. All right, so int zeros equals 0, and then we're going to go for int I equals 0 while I is less than samples dot length plus I. All right, perfect. So we have that. And let's begin. If samples at I is equal to 0, zeros plus plus. Else, so let's talk about this real quick. If the sample we're looking at is 0, then we want to keep adding to zeros our count, because we know we keep going. But here's the thing, there will be zeros that are not consecutive. 5, 8, and 14 are all indexes in that array that are zeros that are not part of the beginning zeros. And notice that we keep those later, right down here at 1, 4, and 15 is also 1, 10 and 11. You can see that we don't get rid of all the zeros in the samples list array. So we don't want to just get up every single zero. So the moment that we have an else condition where we find something that is not a zero, what should we do? Well, there are a few options, and you can choose your favorite. My favorite is the break command. Break right there, perfect. Once we find something that isn't a zero, we break out of that loop. And that's what break does, right? So when we find something that doesn't fit in there, we break. Very easy. Alternatively, there are some other things we could do. We could go ahead and set I equal to samples.length, because then once it gets to the end of the for loop, it's going to go back up here and check to see if it's equal. And since it won't be, or sorry, since if it's less than, and since it's then going to be 1 plus the samples.length, well, you know, it wouldn't be less than anymore, and it would end. Let's see. Add into that, you might throw in there continue, just in case you had a few more lines of code after that inside the for loop. You'd want to skip those, so you can do that. I also saw some students do it with a Boolean, where they had some Boolean that they made up here called, I don't know, flag, and they started off at false, and this was as long as that flag was equal to false, but then in the else statement they set that flag equal to true, so that way they wouldn't count up the zeros anymore. But anyways, you get the idea. Exit the for loop. Alright, so now that we've gotten the length, check, we're going to create snew. And that's actually a very straightforward process. Snew equals new, or we should really do int bracket bracket, snew equals new int bracket samples dot length minus zeros bracket semicolon. So right there we've created our new array that's declared and initialized with length. All right, next up, check. We're going to copy the values into snew. So that means we have to go in a for loop for int I equals 0 while I is less than snew dot length, because remember now we're going to be copying into snew. Samples is much longer probably than snew, so we can't go through all this and try to put all this into here. It won't fit. We're going to have some way to focusing it so that way we can go right like that. And that is done like this. For int I equals 0, while I is less than snew.length plus plus I, we're going to set snew at I equal to samples at I, but here's the thing, we don't want to start it off at the 0 index of samples, do we? We want to start it off at whatever zeros is. So for instance, we have this one where we counted up 1, 2, 3, 4 zeros, so we want to start at index 4 when we copy them into this array. So we'll do samples at I plus zeros, so that way we start 4 ahead. And that's it, actually. Snew at I, that's it for that task anyway, is what I'm saying. So we go through all of those snews places, and we set equal to the corresponding place in samples. Easy. Those values have been copied. Lastly, samples equals snew, which is actually going to be the part that saves our work. So honestly, I'm just going to write that. Samples equals snew. It now has all the properties of snew, which is good because snew is about to disappear at the end right here. And that right there is our solution. Okay, hope you learned something. Please turn in your work. See you next time.